So next is we have to draw the bending moment diagram. Okay, I'll give some clue for drawing the bending moment diagram. You remember these two words, LAN, wrap. LAN, left side, L indicates left side, N is negative moment, A is above the baseline. That means left side negative moment above the baseline. Okay, wrap. R indicates right side, A above the baseline positive moment. P indicates positive moment. So if the right side positive moment, we have to draw above the baseline. Okay, left side negative moment means above the baseline. Right side positive means above the baseline. Suppose if you are getting left side positive, it should be below the baseline. Okay, if you are getting right side negative, it should be below the baseline. Okay, remember these two words, LAN, wrap, LAN, left side negative moment above the baseline, right side positive moment above the baseline. To draw the bending moment diagram, first you draw the given beam, continuous beam. Okay, project all the supports using thin line. Similarly, this load also. Okay, right. Now draw a baseline. Always the baseline is as similar to the given beam. The given beam is the horizontal beam, right? So you have to draw a horizontal line, that is your baseline. Okay, right? Now we have to find each member, we have to consider separately. AB member, first consider AB. AB, A is the left side end and B is the right side end. Okay, so the end which is nearer to your left hand is left end and end which is nearer to the right hand is right end. Okay, so left end A. What is the moment at A point? MAB, that is minus 140.5. Okay, we are getting negative moment. Left side negative means above the baseline. You remember LAN. Left side negative, we are getting minus 140.5. So left side negative moment. Therefore, the bending moment diagram is above the baseline. Okay, so you have to draw a straight line, straight vertical line, which is above the baseline. That value is 140.5. Okay, now coming to B point, right? For AB member, what is the moment at B? MBA, right? MBA, the value is minus 47.5. Right hand, we are getting negative value. See, right hand positive means above the baseline. But here we are getting right hand negative. Therefore, it should be below the baseline. This value is 140.5. Here it is 47.5. So accordingly, we have to draw the line. Approximate scale, we have to draw the line. Okay, here the right hand we are getting negative moment. Right hand positive means above the baseline. Here it is negative, therefore it should be below the baseline. Okay, AB is over. Now you can connect these two lines. Okay, now consider BC, which is your left hand. B is your left hand. That moment is BC. And C is your right hand. That moment is CB. Okay, what is MBC? MBC is 47.5. Okay, left hand you are getting plus 47.5. Okay, left hand plus 47.5. That is our value. But left hand negative means above the baseline. But we are getting positive value. Therefore, it should be below the baseline. Already, this B point itself, we have drawn one vertical straight line of value 47.5. Okay, same point. Okay, now coming to C point. C point, what is your moment? CB, MCB value. MCB is plus 84.16. Okay, plus 84.16. Right hand, you are getting positive value. Right hand positive means above the baseline. Therefore, you draw a line above the baseline at C point. That value is 84.16. Okay, now connect these two. Now consider CD member. CD member, C is your left hand, D is your right hand. Okay, what is the moment at C point? CD. What is the moment at D point? MDC. Okay, what is MCD? MCD value is minus 84.2 kilonewton meter. So MCD means left hand. We have minus 84.2. Left end negative, therefore above the baseline. Land, left end negative above the baseline. So you draw a line at 84.2 value. Okay, above the baseline. Next, D point. D, what is your woman? MDC. MDC is plus 14.5. Okay, positive. Right hand, we have positive 14.5 kilonewton meter. Therefore, right hand positive above the baseline. So you draw a line of value 14.5. So connect these two. This is your end moment. Okay. Now we have to draw the maximum bending moment diagram. Okay. Then only we'll get the net moment. Maximum bending moment diagram. In case of UDL, where the maximum bending moment occurs at the center point, the maximum bending moment is WL square by 8. Okay, WL square by 8 for UDL, which is acting at the center. Maximum bending moment is WL square by 8 and which is acting at the center. So you have to draw, mark the maximum bending moment value, that is WL square by 8, W is 20, L is 6 meter. So WL square by 8 will get 90 kilonewton meter, right? You draw the maximum bending moment diagram. In case of UDL, what is the shape of the bending moment diagram? This is curved line, right? So it is maximum at the center point. Now, BC member, BC also subjected to UDL. The span is 3 meter. Okay, so here we will get the maximum bending moment at center point, that is 1.5 meter. That value WL square by 8 value 22.5 kilonewton meter. Okay, next is CD member. CD member, we have a concentrated load. That load is acting at the center point. Okay, in case of a concentrated load acting at the center, the maximum bending moment formula is WL by 4. Okay, WL by 4. Okay, and where the maximum bending moment occur? Under the concentrated load. Okay, in case of concentrated load, the maximum bending moment occurs under the concentrated load. If it is acting at the center, the formula is WL by 4. If it is eccentrically placed, WAB by L. Okay, so here it is WL by 4. The W value is 50, L is 6, and you'll get 75 kilonewton meter. Okay, which is acting at the under the load. Okay, what is the shape of the bending moment diagram for concentrated load? Inclined straight line. Okay, now we have to shade the remaining load. This is your net bending moment diagram. Okay, see here the maximum bending moment in case of UDL, which is acting at the center, then the formula is WL square by 8. We got it is 90 kilonewton meter. Concentrated load acting at center, the maximum bending moment formula is WL by 4, which will be under the load. Okay, so that we got 75 kilonewton meter for CD member. Suppose a concentrated load eccentrically placed, which is A distance from left hand and B distance from right hand, means the formula is WAB by L, where it is occurs under the concentrated load. Okay, so this is the procedure for finding the bending moment for a continuous beam. I hope this video will help you for analyzing a continuous beam using slope deflection method. Thank you.